In this video, I'm going to discuss the idea of the natural exponential function as well as one of its applications. The natural exponential function is the function f of x equal to e to the x. And this value e is known as Euler's number. This is an irrational number, just like pi, and it comes up a lot in math applications. And it is approximately 2.71828182845, etc. So this number goes on forever and never repeats. The application I'm going to look at here is going to be compound interest. So let's think about what this means. P is going to be the amount invested or loaned. R is my interest rate. T is the time in years. And then N is the number of times that we compound per year. So how often is the interest calculated? In that case, the amount in the account is going to be P times 1 plus R over N raised to the NT power. And if we compound our interest continually, if interest is continuously calculated, then we use the formula A equal to P to the RT. So let's look at some examples using this. I want to suppose $8,000 is invested at 4.5% interest for 5 years. How much is in the account if it is compounded annually? So we need 4 numbers, P, R, T, and N. P is the amount invested, that's $8,000. R is our interest rate, so 0.045. T is time, we had this for 5 years. And for this one, we are compounding annually, so once a year. My formula said A equal to P times 1 plus R over N to the NT. So this will be 8,000 times 1 plus 0.045 over 1 raised to the 1 times 5 power. This is the same thing as 8,000 times 1.24618, which comes out to that we would have $9,969.46 if this was compounded annually. I'm now going to do the same problem, but this time I'm going to compound quarterly. Quarterly means that we break the year up into 4 pieces, so n is equal to 4. This time I would have 8,000 times 1 plus 0.045 over 4 raised to the 4 times 5 power. This is the same thing as 8,000 times 1.25076, which would give us $10,006.00. This time, we're going to compound monthly, so 12 times a year, since there are 12 months in a year. That would be 8,000 times 1 plus 0.045 over 12 raised to the 12 times 5 power. This would give me 8,000. This gives me 1.25180 when I round, which gives me that I would have $10,014.37 after 5 years. This time I'm going to compound daily, so 365 times a year. This would give me 8,000 times 1 plus 0.045 over 365 raised to the 365 times 5 power. This gives me 8,000 times 1.25231 which gives that I would have $10,018.44. So we can see from these examples that the more times I compound, the more money would be in the account. Finally, I'm going to do this same problem, but this time interest is going to be compounded continuously. So this time I'm going to be using A equal to P times e to the RT. We know that P is 8,000 just like it has been. R is 0.045 and T is 5. This becomes 8,000 times E to the 0.225 power. We can use calculators to calculate e to the 0.225. We get 1.25232. And then multiplying by 8,000 gives us that we would have $10,018.58.